Alright, so from Chapter 5, Section 2, we're using this substitution step, and I alluded that I'm going to let u equal 4 minus root x, which that is equivalent to 4 minus x to the 1/2. And I also want to find out what the derivative of u is with respect to x. So when I do that, derivative of the 4 is 0. The derivative of negative x to the 1/2 would be negative 1/2 x to the negative 1/2. That's what that is, right? We see that, the derivative of u with respect to x, I could actually substitute that in. Because du dx is equal to this negative 1/2. Instead of writing x to the negative 1/2, I could put x to the 1/2 in the denominator. Get rid of the negative exponent. So they are similar to each other. So what I'm going to have is this integration of 4 minus root x, which we've called u, squared. This thing is my du dx, and then I still have that dx. And if you look at it, appears that they cancel out, and so we're going to go with that. It's a little bit different, but algebraically it seems to fit what we think should happen. So I have this u squared du. Well, that's just a simple power rule. So I would add 1 to the exponent, and then divide by that exponent, and then put a plus c. And I've found the integral. I've integrated it, the indefinite integral. The last thing that I should do, though, is put in what is u really equal to, because I started with an x, I should end with the x. And we know that u equals 4 minus root x. So 4 minus root x cubed over 3 plus c. And the thing is, if we take the derivative of this, we should get exactly what we started with. We would get this. So that's a way you can always check to see if you've done it correctly. With the second one, I believe it was yellow's number 4, this one seems kind of easy, but it's got a little bit of a tricky part to it. So here we have this derivative, right? X times, this is a derivative, I want to find the antiderivative. So I need to see what could I take the derivative of to help me eliminate one of them. And so if we let u equal this 3 minus 9x squared, the derivative of that with respect to x would be equal to negative 18x. So that's not exactly what I have, right? I have x, not negative 18x. So what I could do is maybe add an 18 or a negative 18. And so I'm going to rewrite my problem, and I'm going to say negative 18 over negative 18x. 3 minus 9x squared raised to the 5th dx. So hopefully we agree that by adding negative 18 over negative 18, I haven't changed it any. Block this off. So what I'm going to do now, using that constant rule that we have, I'm going to pull out that bottom negative 18. So I have 1 over negative 18 on the outside. I have a negative 18x, 3 minus 9x squared raised to the 5th dx. Now I can do my substitution step. Negative 1/18. Negative 18x is my du dx. So I have a du dx. 3 minus 9x squared, that's my u. U to the 5th dx. A little rearranging. I have u to the 5th du dx, right? But I'm multiplying by a dx, kind of. And so I just have du. And so now I turn it into this power rule. Negative 1/18 u to the 6 over 6 plus some constant. Always remember that plus constant. So that would give me 18 times 6 is 108. And then lastly, we know what u is. U is 3 minus 9x squared. So my antiderivative is negative 1 over 108. My u is 3 minus 9x squared raised to the 6 plus c. So it's that substitution step that's going to help me eliminate some piece. In this case, I had an x out front. I had to manipulate it by a constant, that negative 18, a special 1 that I added to the mix. By the way, 1 and 0, that is my favorite number because there's so many ways that you can manipulate those things. But I end up getting my antiderivative after doing some substitution. One more that I wanted to look at is, let me make sure I'm start up at the top. And so I have this is my number 5. That was raised to the 9th. And so a lot of times the thing that's in the parentheses is the thing that's going to be your u. It's not always, but a lot of the times. So x squared plus 6x plus 8. And the derivative of that with respect to x is 2x plus 6. So I really don't have a 2x plus 6, right? I have a 16x plus 48. But I could write this, if I wanted this to be a 2x, I would factor out an 8, and maybe we'll see something appear. So that would be 2x plus 6, my du dx. So with a little manipulation, we're going to be able to do some substitution. So I could pull that 8 out if I want. 2x plus 6 is my du dx, right? So I'm going to get 1 over u to the 9th. And again, if this is my du dx, and I'm multiplying by a dx, I just have a du. So I can make this one look a little different. U to the negative 9 du, and now I can use my power rule. So I have 8 u to the, if I add 1, I get negative 8, and I divide by negative 8, plus c, and lastly, say what my u is. Oh, and my 8's kind of cancel out too, right? So I have negative x squared plus 6x plus 8 raised to the negative 8 plus c would be the antiderivative, and that's what we're finding in most of the ones from chapter 5.